Okay, so in this video, we're going to start looking at financial maths. And the first thing we're going to take a look at is in your log tables, here under financial maths, we're going to go to page 30. And here we have your formula for your financial maths, okay? And this one here, for the compound interest, you would have come across, of course, at junior cycle. You would have done some work at higher level on compound interest formula, and also looked at the depreciation formula as well. So these two here, we're going to jot them down. Now, if you're not familiar with these, I do advise you to go and look up. There's a video lesson on compound interest at junior cycle, and I go into a lot of detail as to how we kind of can come up with this type of a formula and then how to use it as well. Okay, so I really do urge you to have a look at that first. It'll give you a great grounding now before we get on to the trickier questions at the start of our Leaving Cert Financial Maths. And so if you're already comfortable with these two formula, the first thing I want to look at now is rates. Okay, so a big difference between junior cycle and senior cycle with financial maths is that at junior cycle, you only would have dealt with a rate and an annual rate, but at senior cycle, you have to be able to not only deal with an annual rate, but be able to use that annual rate to calculate monthly rates as well, okay? So one of the first things you need to get clear from your question is you need to ask yourself, do the rates match? And what I mean by that is, so do the rates match? So what I mean by that is, do you have an annual rate? Are you given an annual rate in the question? For example, maybe 5%, and you're told that's the APR or maybe AER, okay? They imply their annual rates. But maybe it is compounded annually. So if it's an annual rate and it's compounded annually, they match. That's fine. That rate matches how it's compounded. But maybe you're given an annual rate and it's compounded monthly, or maybe you're giving an annual rate and it's compounded quarterly. Now that's when you've got an issue. And if the rates don't match, i.e. you're given an annual rate and it is compounded not annually, but another way, then you have to change that rate. You're going to have to calculate then the monthly rate or the quarterly rate if all you're given initially is the annual rate. Maybe though you are given a monthly rate and you're told it's compounded monthly, therefore it matches, so that's fine. There's no calculation needed if it matches. Maybe you're given a quarterly rate and it's compounded quarterly, so again that's okay. It's when it doesn't match. If you're given an annual rate and it's not compounded annually, it's compounded in some other way, then you have a calculation to do in order to get the rates to match. Okay, so the way we work this out, so if you're given an annual rate and you need to calculate then what the monthly interest is on that because you're being told that they're earning interest and it's being compounded monthly, then you're doing, of course, your percentage increase. So you're multiplying by 1 plus your rate, okay? If you're compounding monthly, you're going to have 12 of these multiplications. So you'll be multiplying by 1 plus the decimal form of your rate once, and again multiplying by 1 plus that rate, and again multiplying by 1 plus that rate, and so on 12 times because there's 12 months in the year. And that is going to equal what your annual rate is, okay? And that's what we'll put in here, 1 plus, and I, of course, is, of course, the decimal form of the rate. Now, I'm going to go through an example so you'll see this in action in a second. If it's quarterly, though, again, you'll set up this equation, but this time you will have 4 of those in the year. So if you have a yearly rate, but you're compounding the interest quarterly, you're going to have 4 of them has got to equal the yearly rate. Okay, so let's jump straight into an example so you'll see this at play. Okay, so here we go. What monthly rate of interest, corrected 2 places of decimals, is equivalent to an annual rate of 6%? Let's just work out what the monthly rate is if we have an annual rate. Okay, so the first thing I'm going to write down for myself is my 1 plus r. It's monthly and there are 12 months in a year. So it's 1 plus r to the power of 12 must be equal to the annual rate 1 plus I. Now, I don't know what that monthly rate is. That's what I'm calling R. But I do know the decimal form of the annual rate is going to be 0.06 from the 6%. Okay, so I basically have 1 plus r to the power of 12 is equal to 1.06. And so I need to now solve for r. So the first thing I'm going to have to do is get rid of the power of 12. So to undo that, I'm going to get the 12th root of 1.06. And then I'm going to subtract 1 from both sides to get r on its own. So to be the 12th root of 1.06, take away 1. And I'm going to do that on the calculator now. So to get the 12th root, I'm going to need to get this up here to be able to put in the 12 before the root. So I'm going to press Shift and then put in the 12, put in the 1.06, press equals and take away the 1, of course. Now here we go. So you've got a bit of standard form going on here, which means that that decimal place, because you've got a power of a minus, it's going to move 3 places to the left, okay? If I add 1 back onto it there is the rate before I subtracted the 1, so you'll see where the decimal is going to be. You're going to take away that 1 and going to be left with 0.004867551. It's a good idea to jot down the whole thing. And then we'll round it to our 2 places of decimals. So we have 0.004867551. So that is your rate in decimal form. To get it as a percentage, of course, multiply by 100. And I'm getting to 2 decimal places, 0.49%. Okay, I'm going to do this question now. Again, I want the monthly rate if there's an annual rate of 2.5%. So again, I'm going to start off with this. So you're really going to want to remember this, okay? And learn it off if you have to, but this is always how you're going to start off whenever you're doing your conversion. If it's monthly, it'll be the power of 12. If it's quarterly, the power of 4, or how many times you're compounding a rate within the year. Okay, so that's how you know what that power changes to. Good news is mostly you're only asked about a monthly rate, really. If you're given an annual rate, the change is usually to monthly, but you may be asked quarterly, so you just want to be familiar with how you would just adapt that. Okay, so this time, again, I don't know my R, but I know that the rate is 2.5, so 2.5% as a decimal is 0.025. So again, to undo the power of 12, I am going to do the 12th root. And I'm going to take away 1. So the 12th root of 1.025, subtract 1. That's what I'm going to do on the calculator. So get the 12th root. Again, by pressing this button, I'll just do that again. So Shift, 12, and then put in your 1.025. Okay, and then subtract 1. Again, it's coming up in standard form. So if you want to leave it like that for yourself, and know you're going to take that 1 away. In decimal form, we're getting 0.00205986. And of course, as a percentage, then to 2 decimal place, multiply by 100, it is 0.21%. Okay, so let's have a look at this question now. This isn't as straightforward a question about rates as the previous one, okay? But I want to show you exactly how we can apply the same strategy with a question like this and how to spot what to do. We have an investment bond, offers a return of 15% if invested for 4 years. Calculate the AER for this bond, correct 2 places of decimals. Now here, what we have is we have 15%, which is the total percentage that it's going to give you a return on for 4 years. So it's 15% over that 4-year period. It's not 15% per year. And so what they're asking me to find out is what is that rate then per year if it's giving 15% overall in the 4 years. So here, what we have is we have a rate that's going to be compounded every year for 4 years. So it's going to be compounded 4 times. and it's going to equate to an overall rate of 15%. So that's 1 plus, and of course your I, in this case, is the decimal form of 15%. Over the whole life of the bond, which happens to be 4 years, the 15% has to represent whatever that rate is that's compounded 4 times. So it's a yearly rate compounded 4 times to give an overall rate of 15%. So do you see the way we're looking at this? So I have 1 plus r to the power of 4 is equal to 1.15. This time, of course, I want to undo the power of 4. So I will 4th root that. And I will, of course, take away 1. So on the calculator, I'm going to do the 4th root of 1.15. Oops. There we go. Take away 1. And I'm getting this 0.035555807,634. And of course, multiply by 100 to get the rate in decimal form. And they want it to 2 decimal places, so 3.56%. Okay, so let's have a look at this question. Sean invested €4,500 for 5 years in Euro Bank. His investment amounted to €5,607.82 at the end of its term. Find the AER, so the annual rate, that applied to his investment. So get your formula written down and let's fill in what pieces of information that we know. So F, remember, is of course the future value, and that is what we are getting at the end of the term, 5607.82. P is the principal amount, which is 4,500, in other words, what we started off with. 1 plus, I is of course what we don't know. We don't know what the rate is, but we do know the time is 5 years. Okay, that annual rate is being compounded over 5. $1.24618222. Now, don't round at this point, okay? We're still in the middle of a calculation. You shouldn't round until the very, very end. So a good rule of thumb is just to write out the whole calculator display. And then we need to get rid of the power of 5. So we're going to do the 5th root of this. That'll leave you with 1 plus I. And of course, we'll take away 1 from both sides. So on my calculator, I'm doing the 5th root of that, take away 1. So 0.045000. That, of course, is the decimal form. So multiply by 100, 4.5% was the annual rate. Let's take a look at this rates question. Camille asks for interest to be added half yearly to his account. If the bank offers an AER of 4%, find correct to 4 significant figures the equivalent half yearly rate. Okay, so we have an annual rate and we want the half yearly rate. So straight away, let's take down our little formula, if you like, for our rate. Okay. But this time, how many times is it being compounded within the year? When we were looking for a monthly rate, we did a power of 12 because if it was being compounded monthly, there would be 12 of those within the year. If it was quarterly, you're going to have the rate compounded 4 times within the year. Here, it's a half yearly rate, which means you're going to have it compounded twice within the year. So 1 plus r to the power of 2 is equal to 1 plus, and decimal form of that annual rate is 0.04 for 4%. So I have 1 plus r squared, all to be squared, is equal to 1.04. To undo the square, of course, I will square root, and then I will take away 1. So I'm getting 0.01980. 390272. And of course, that's the decimal form. So multiply by 100, and I'm getting 1.98039, so on. I want 4 significant figures. For significant figures, you count, there's your first significant figure, second significant figure, third significant figure, and a 0 between numbers is also significant. So there's your 4th significant figure. Look at the number afterwards. 3 will not change that 0 or bump it up. So 0.1980% is the answer. Okay, so here's a question. Find the future value of 6,500 euros invested for 6 years, 4 months, if the monthly equivalent rate is 1.932%. Now, here's where we are going to use our compound interest formula, but we've got to do a little double check on rates here, okay? Remember, I asked you to always ask yourself, do the rates match? Now, what's happening here is we do have a time frame in years and months, and our rate is monthly, okay? Now, what I'm going to have to do then is, if I've got a monthly rate, I'm going to need my time all in months, okay, for me to be able to work this out and put all the information into my compound interest formula. Okay, so everything has to kind of match up. We're okay with the monthly rate. I don't need to do an extra calculation on that, as long as then I'm considering the investment in a monthly way. Okay, so 6 years and 4 months. Well, 6 years is going to be 6 times 12, 72 months, and another 4 months. That's going to be altogether 76 months. So I want to find the future value, so I don't know what that F is. If the 6,500 is our principal amount that's being invested, the rate is fine. It is 1.932%. Now, that is it as a percentage. Divide by 100 to get that as a decimal. The I always needs to be filled in decimal form. So 1.932 divided by 100 is 0.01932. And the time now, once that's all in months, I can do that to the power of 76. Now I've got a monthly time frame and a monthly rate. So on the calculator, 6,500, and I'm going to put in 1 plus 0.01932 to the power of 76. So get it typed in exactly as you have it. And there's my answer. And of course, it's money, so we'll do 2 decimal places. Okay, so take a look at this question. So we have 12,000 euros is invested at an AER of 3.5%. Find the value of the investment after 5 years and 3 months. Now, we have an AER, and we've got a mix of years and months here, which is a bit of an issue. So either we figure out a monthly rate and convert this all into months, or we get the time frame in terms of years and stick with the yearly rate. Do you see? They've got to match. Okay, so I'm going to go with the quickest calculation here, which is just to convert the 5 years and 3 months into years. Okay, so 3 months is 3 out of 12 years, isn't it? There's 3 months out of 12 in terms of years. So 3 divided by 12 is, of course, 0.25 years. That's what the 3 months is in decimal form in years. So if I have 5 years and 0.25 years for the 3 months, that is a total 5 years and 3 months is 5.25 years altogether. Now I've got it in terms of years and I've got a yearly rate. So I'm going to jump straight into my formula. I want the future value. 12,000 is the principal value that's invested. The rate, the decimal form of that rate, divide 3.5 by 100 is 0.035, and the time is 5.25. And there we go. That's it all typed into the calculator, and there's my answer. $14,375.34. Okay, last question. Let's have a look at this. 50,000 euros is invested in a bank offering an AER of 3.5%. How long will it take this investment to double in value? So here's just another type of question that will involve our compound interest formula. So I'm going to get that written down for myself. And we have a principal value. It is, of course, 50,000, so fill that in. The interest rate in decimal form is 0.035. Take the 3.5%, divide by 100. And I'm obviously looking for how long it's going to take. So I'm looking for T. The investment needs to double in value. So double 50,000 is going to be 100,000. Okay, so I want to know how long it's going to take for this, at this rate, to get to 100,000. So this is what I'm going to look to do. And the first thing I'm going to do here is I'm going to get rid of that 50,000 that's being multiplied. And of course, this is 2. And I have 1.035 to the power of t. Now, let's use our logs. How we solve for powers. We can bring in logs here. So remember, when you're doing your logs, you're filling in your boxes here going from power form to log form. The power is what your log is always equal to. What's being raised? 1.035 is the base, what's being raised, and 2 obviously goes in here. So I can do this on the calculator then, putting up my logs and putting in your base, 1.035, and your 2, we're getting 20.14879. So it doesn't ask me here to round or anything. I suppose it would take into the 21st year. So you could probably say 21 years. But I'd be reluctant to round since it doesn't ask me to. So I would give 20.15 or 20.1488 years getting. So keeping with the decimal is only going to give extra accuracy here. So it's useful to keep it like that since it has to ask to round.